Alg1B. This is our second lesson reviewing standard form of a line. Should be pretty quick. We're going to review the standard form as ax plus by equals c. We will graph, and that might just be the whole show today. Well, I guess we'll see. Okay, that is too thick. Remember last time we talked about how to graph slope-intercept. Here the y-intercept is 1, and the slope is going down 3 and right 2, so it's going like this. And negative slope means you go down as you go to the right, so down 3, right 2, down 3, right 2. Once you've gone down and right, you can go up and left. This line would look kind of like this. It's a very quick sketch. Well, standard form is ax plus by equals c. The x's and y's are together. In the future, I'm going to call this a side-by-side equation because the variables are right next to each other. We can find the x-intercept by calculating the c term divided by the a term. The y-intercept is c divided by b. And a lot of people don't talk about this, but the slope is negative a over b. That can be pretty useful sometimes. So I'm just going to quickly graph 4x minus 2y equals 12. 4x minus 2y equals. In this equation, my a value is 4, my b value is negative 2, and my c value is 12. The fact that b is negative 2 and not just 2 is very important. The signs are very important with these. Now if I want to find the x-intercept, I can just do c divided by a, which is 12 divided by 4, which is 3. Think of that as the point 30. So that is right here. This is my x-intercept, it's the point 30. If I want to find the y-intercept, that is c divided by b, which is going to be 12 divided by negative 2, which is negative 6. Think of that as the point 0, negative 6. And if I just connect these two dots, I have a line. That actually went pretty well. However, I can also find some more points by using the slope. I know the slope, which we use letter m for, is negative a divided by b, which is going to be negative 4 divided by negative 2, which is just 2. The slope of this line is 2 over 1, so up 2, right 1, up 2, right 1, up 2, right 1. You can see my line that I drew kind of got off a little bit. I wonder if I can fix it. Yeah, that's better. This is my line 4x minus 2y equals 12. Remember, whenever you're graphing a line, label it and put some points. Like I want to make sure I know that this is the point 0, negative 6. I have the point 30. I'll add one more. This is the point 54. I'm going to use a checkpoint to make sure that I've done this correctly. So I'm going to shrink this down and pull it off to the side. And let's check this in a nice, pretty little pink color. I'm going to take the point 54. I'm going to plug in, I'm going to take my equation, always write the initial equation first. I'm going to plug in 5 for x, 4 for y, and I hope this comes out to 12. So I put that little question mark there. This is a question equals sign, like I'm checking. Does one side equal the other? Well, 20 minus 8 does in fact equal 12. So yes, my checkpoint is good, my line is good. I'm going to make a quick table showing some points. I'll go in order, so I have 0, negative 6. I had the point 30, and I had the point 54. That'll be enough for now. Okay, that's graphing standard form. It's pretty straightforward. Let's ask the question, how do we graph if one of the intercepts isn't clean? And by clean, I mean an integer, a whole number, positive or negative. Integer means positive or negative whole number. So here, to find the x-intercept, I do c divided by a, which is 10 divided by 5, which is 2. It's the point 20. But to find the y-intercept, I again do c divided by b, but c divided by b is 10 divided by negative 3, which is negative 3.3 repeating. Graphing the x-intercept at 20 is fine, But graphing negative 3.3, I'm not really sure how to make that work. And then, like, I don't know if that's precise or not. And then finding more points, like I could connect the dots and kind of hope for the best. But because I wasn't using a precise initial point on my y-axis, I'm not totally confident with that graphing. But what I can do is plot a slope. I know the slope is negative a divided by b, which is negative 5 divided by negative 3, which is 5 over 3. So from this point here, from my x-intercept at 2, 0, I'm going to go up 5 and right 3 and put a point there. I can also now go down 5 and left 3 and put another point there. That is going to give me 3 good clean points that I am confident in, that I know are correct, and let me graph this well. So I had the point 2, 0, had the point 5, 5, and I had the point negative 1, negative 5 for the line 5x minus 3y equals 10. My table is the same, negative 1, negative 5, 2, 0, 5, 5. You'll notice if I compare the changes in x and y, this is going from negative 1 to 2 is up 3, and from 2 to 5 is up 3, which is also the run of the slope. And from negative 5 to 0 is up 5, and from 0 to 5 is up 5, and that is the rise of the slope, which makes sense because x is the run, and y is the rise, and slope is rise over run. Real quick, I want to talk about why these formulas are c over a and c over b and negative a over b. To find an x-intercept, that means the y value must be 0. If the y value is 0, I can plug 0 in for y, plug 0 in right here, and this just becomes 0. So I get 5x equals 10, which means that x equals 2. I got 2 by doing 10 divided by 5, and 10 divided by 5 was this exact process. So the x-intercept is c divided by a, because it's like this stuff goes away when you find the x-intercept. And if you want to find the y-intercept, it's like this stuff goes away, because to find the y-intercept, the x value must be 0. Finally, if I want to find slope, I would just get the y by itself. Like if I had the equation 5x minus 3y equals 10, and I wanted to convert into slope-intercept form, I would subtract a 5x from both sides and get negative 3y equals negative 5x plus 10. I would then divide everything by negative 3, and that would give me y equals 5 over 3x minus 10 thirds, or 3.3 repeating. That's that kind of funky y-intercept we were just talking about, but here's me converting into slope-intercept form. If for some reason, this will be the last thing I'm going to kind of sneak in here, and when I say some reason, I mean like on your upcoming homework. If for some reason you wanted to go from standard form to slope-intercept form, you take that process and do it backwards. Like suppose instead I was given a standard form equation. I'm going to make up a new one now. Let's say it was y equals 2 thirds x minus 3. The first thing I would do, I'll make it minus 4. The first thing I would do is get rid of this fraction. The best way to get rid of that fraction is to multiply everything by 3. And I mean everything gets multiplied by 3. That's going to become 3y equals 2x minus 12. This 3 distributes. 3 times negative 4 is negative 12. 3 times 2 thirds is just 2. Then I just want to get the x's and y's together, so I'm going to subtract 2x from both sides, and that becomes negative 2x plus 3y equals negative 12. We really like it if our first term is positive, so I'm going to switch everything's sign. It's like I multiplied everything by negative 1. That's converting from standard form to slope-intercept, from slope-intercept to standard. Just get the x's and y's together and clear your fractions. Okay, so to recap, standard form is ax plus by equals c. The x-intercept is at c over a. The y-intercept is at c over b. And the slope is negative a over b. And you can convert between forms by just doing some basic solving. Next video, we'll talk about some word problems. Here's one we'll discuss. There are 10 cookies. You and your brother plan to eat them. How can we express this mathematically? Okay, maybe think about that. We'll talk about it next video. Thanks for watching. See you next time. Hey, thanks for watching. I hope you found this helpful. If you did, please like it and subscribe it and share it and do all those good things. Or you can just sit there and be distracted by my spirograph as it goes around and around forever. Just going and going and bouncing and bouncing. See you next time.